Hey guys, welcome back to our second video in this subtopic of resistance in Eastern Europe and nuclear weapons. So in our first video, we covered the Eastern European part of things. Today, in this video, we're going to cover nuclear weapons, how they're developing and getting stronger and getting more deadly in the Cold War. And of course, this requires us to go back and think about the development of nuclear weapons during World War II. This was a major project, a secret project that America carried out. Took years and billions of dollars to fulfill that promise of developing nuclear weapons. And so, because of all that, America was pretty confident that they would have a monopoly over the atomic bomb. In other words, they would be the only nuclear country for years to come. Now, I mean, they were realistic. They knew that the Soviets were working on a bomb and eventually they would develop one, but most experts believe it would take at least a decade, maybe even more than that, to develop an atomic bomb. And so, America was shocked when, in August of 1949, the Soviets detonated their very first atomic bomb. This is just basically 4 years after the end of World War II. This was way before anybody thought the Soviets would have this weapon. I mean, this was incredibly shocking to have. Stalin now has an atomic bomb. That's pretty scary. Now, what explains this rapid development? Well, it's partly that Soviets, they had really good scientists, just like Americans did, but also they had a lot of spies, and so they were able to get some of this, some of the stuff that we had been working on. They basically were able to get it and then accelerate their own program by taking that information. Now, we had to respond to this in a big way, and the decision was that we've got to develop even deadlier atomic bombs, these things called hydrogen bombs. And what a hydrogen bomb, or H-bomb, does is, instead of doing fission, where you split atoms apart, which is the process for a regular old atomic bomb, with a hydrogen bomb, you're using fusion, where you're fusing atoms together. It's basically the same process that's going on in the sun. So in other words, you're basically like replicating the sun in miniature form in a bomb. And this is going to give you power that is just almost unimaginable with these types of bombs. The father of this hydrogen bomb was a scientist named Edward Teller. He was quite enthusiastic about developing these bombs. And these bombs, when I say they're more powerful, I mean they could be upwards of 1,000 times more powerful than regular old atomic bombs. So imagine Nagasaki times 100, or times 500, or times 1,000. It's a level of destruction that's almost unimaginable. And we tested this very first bomb in 1952. There's a hydrogen bomb being exploded. The Soviets, of course, then have to race to develop their own hydrogen bomb, which they do by 1953. And so they've caught up with us once again. So if we're both building hydrogen bombs at this point, in other words, the most powerful bombs ever devised, how do you get the advantage going forward in the Cold War? And the way you get the advantage back is by developing more of those bombs. So now there's a race to develop more and more atomic and hydrogen bombs. Mass production, guys. And also the airplanes to deliver them. And you can see the stockpiles of nuclear bombs. They get into just crazy tens of thousands of nuclear bombs. These are more bombs than you could ever use in a war, many times over. This is really levels of insanity if you really stop and think about it. But it becomes this war of numbers, that if we have this number, then they have that. We've got to have more, And it's this constant race to develop more and more and more, even when it doesn't make sense to develop more and more and more. Here's an example of one of those airplanes, the B-52 Stratofortress, which, by the way, is still in service today. All right, so if you're going to develop and deliver an atomic bomb by airplane, there's a built-in weakness. And that built-in weakness, well, there's really two. Number one, the safety of the crew. The airplane could be shot down. also the airplane has to return back to where it took off, so it can only go so far before it has to turn around and run out of fuel. So if you want to get around those weaknesses, you have to send a nuclear bomb on a one-way trip without a crew on board, and that means missiles. So by the 1960s, both sides had developed these things called intercontinental ballistic missiles, or ICBMs. And these are long-range missiles capable of carrying nuclear warheads. So you can fire one of these things off. They go basically up to space and then come back down. They can travel thousands and thousands of miles. And again, you don't have to worry about the safety of the crew because there's no crew on board. It's a one-way trip. And so silos, as they're called, were built across the Soviet Union and the United States to house these missiles so they could take off after a moment's notice. Also, some of these nuclear missiles were put onto vehicles so they could travel around, so they're not restricted to just one place. And these missiles could also eventually be put onto submarines. So now the submarine can lurk off the coast of your country, and they could fire these things away, giving the other country almost no warning at all before they land on them. Then by the 1970s, the technicians developed something called the Multiple Independently Targetable Reentry Vehicles, or MIRVS for short. Well, what in the world is a MIRV? Well, it is a missile that carries, again, multiple independently targetable reentry vehicles. In other words, it is one missile that carries multiple nuclear warheads. Each of these warheads are capable of going to different places because they're all independently targetable. So one missile can now wipe out multiple targets. This is how the MIRV works. Again, the missile goes up, the warheads spread out, and then they all fall on different targets. So what we have here is a pretty good cartoon about the problem that we've run into now with these nuclear weapons. And you'll notice that the armies are firing not the nuclear missiles, but rather arrows. And, well, why aren't they taking advantage of these weapons? They've spent lots of money on them. Why not use them? And the answer, of course, is if they do, the other side will retaliate. They'll respond in kind. This brings us to a concept known as mutually assured destruction, or MAD for short. And what mutually assured destruction is all about is this realization that if I fire off my nuclear missiles, the other side's going to fire them off as well, and that neither side is really going to survive. In other words, you can't really win a nuclear war. That both sides are going to retaliate, and therefore even the so-called winner is going to be damaged beyond belief. And therefore MAD actually makes nuclear war less likely. If both sides are holding these nuclear bombs over the other, they know they can't let go for fear of the other side letting go of their own. And so therefore nuclear war doesn't happen. And it never has, at least not yet, right? And so this is something that's going to guide Cold War thinking going forward, is keeping this balance so that neither side feels like they are vulnerable, because if they feel like they're vulnerable, they might go ahead and launch because they have nothing to lose. So maintaining that balance was really, really important. Alright guys, that's a short video, but I think we've gone through some of the new technologies like the hydrogen bomb, the ICBMs, MIRVs, MAD, all these new concepts that are making the Cold War so much more deadly, but ironically enough, potentially deadly, not deadly in the real sense, and that these weapons are so powerful, thankfully they've never actually been used in the modern context. Alright guys, that's it. In our next video, we're going to move on and look at some other topics in the Cold War.